Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be looking at Linux system performance monitoring tools right after this. So one of the things that you can do with any Linux distribution is you can look at the performance statistics for your particular set of applications that are running. You can then go into your etc syscontrol.config file. You can make modifications in there that will aid your application in performing better. And you know, if you're doing tuning, and I'll be talking more about this in future videos on some of the steps you can follow to get the most performance out of your Linux system. But you know, the first part of it is you need to know what your system's doing, and these tools help you identify how your system is performing, where it's bottlenecking, if there are particular issues. Maybe you have too high of an application load, maybe your IOs are overloading your disk channels, maybe your network is overloaded, and these kind of tools will help pinpoint what's going on. So one of the first ones we're going to look at is one of the oldest ones. This came out of the Berkeley Systems distribution way back when it was still managed and being worked on by the University of California at Berkeley. So this tool was not in the original AT&T System 5 release. It was merged in later with the System 5 version 4 releases, which merged Berkeley with the AT&T System 5. The GNU Foundation wrote one that looked like VMstat, but this is a different version, of course, than the one that ran on Berkeley. Now, if you have a Berkeley system release, your version of VMstat is the original. So just to give you some idea, I'm going to run VMstat with a 10, and that says resample the system every 10 seconds. So some of the information, this is not a tool that is, you know, great, but it does give you some information. It will tell you how many processes are currently executing on the processors. It doesn't tell you how many tasks are actually lined up in the schedule queue, and you know, it just tells you which ones are actually executing inside of a processor. So in this case, we have one, and it's OBS. And then if there's any that's blocked, they'll be here. If there's any that are swapped out, the count will be here. And of course, then you have your memory section, which is free, buffer, and cache. So these are the three areas that you would be most concerned about, would be looking at how much free memory you have left. Maybe you're interested in this if you have a lot of disk and a lot of different, and maybe you're bringing in a lot of data that you just want to have cache so that you can use it. This is the number of swaps in and out per second. So that's what that tells you. And this is the number of bytes in and out per second. On this column, and these don't line up, I think if you run it with the wide option, and I don't have enough room on my screen to do that without covering my video, but they will line up with the -W command. So in the short form, I've never seen this line up ever. But you have this column let me get over here so I'll make sure I'm on the right one. There. So this column right here is the interrupts. This tells you how many interrupts per second your system is doing. This is context switches, the next column over. Context switches have to do when there are page in and page outs. They also occur, a context switch also occurs when the Linux kernel switches execution from one process to another. So yeah, it has to save the state of the old one and then roll the new one in. Then you have the user percent of the CPU. That would be in this section right here. So we have about 14% of user. This would be the CPU is executing user code. That is code that is executing in the user space. This was system. This would be 3% of the system. The code is running in the system space. So 3% of my processors are being used by Linux. 83% idle. That's what the ID is. This would be waiting for an IO or waiting for some kind of block. So I would have an indication over here, and then I would know over here which ones were waiting for IO. For example, this is stealing. Stealing is used typically in virtual machines because they steal execution cycles from the main processor. So if you're using a hypervisor that is running under Linux, then this would be, if I brought up a VM right now, you would start to see a percentage of the time that the CPU was spending executing stolen processes from the VM. So that's typically how that works. This is not the best tool, but I guarantee you that no matter what Linux distribution you have, this one will be on it. So if you haven't got everything installed yet and you've already run into a problem with performance, then this would be probably the first one you would turn to. There's also a little bit better one that you can use called iostat. It has the same mechanism. You can give it how often you want to recycle, how often you want to refresh the data. So this one has some color coding, which is kind of nice, and this kind of helps visually identify where there's a problem. Where there's a problem area. And the blue means everything is normal. Everything's fine. It's within the normal limits of the system. And then you'll notice this is average CPU, so this is an aggregate of all the CPUs and threads in the system. So 14% of the user processes are executing. 14% of the processors are executing user processes. Nice is a way to tell a process to back off or to take, it's basically a way to prioritize what applications get more cycles on the CPU or less. The higher the number in the positive direction of nice, the less execution time they get on the processor. You can go negative, and if you do that, then they get more cycles on the CPU. And you'll probably notice if you look on a top or your htop, you'll probably see nice listed, and you'll see some processes in there that on Linux that run at -20. That's normal because they get priority. If there's a problem, they come in and they do their job and they leave. If they can't get cycles on the processor, your machine could just hang. And so those things are kind of necessary in order to keep things running. I don't advise that you run anything with. I don't advise that you run user processes negative unless I guess there might be occasion to do it. But really, it's more system processes that run in the negative, not in user space. But anyway, that's convention again, not a rule. So how much of the time the processor is being spent in the kernel? How much of it is waiting for I/O? This is steal again. This again back same definition as before. It's the VMs, and then idle. I always think this is humorous that it shows red. So the color schemes in here are blue is normal, purple is watch out. You're starting to approach. It doesn't mean you have a problem yet. It just means that you're starting to approach the limit. Where it will click over into the red. And once you get into the red, that means you've got a problem. Yeah, I don't think idle is a problem, but it does show that. So, but I always thought that was humorous with that particular tool. So let's see how it might work. I'm going to fire up a program called sysbench, which will put a little bit of stress on the processor. Now this one, it won't give you a whole lot of meaningful information, but I'll just tell you it runs 4 times. It runs with 1 thread, 2 threads, 4 threads, and 8 threads. So and so you should start seeing the idle times coming down, and the user times going up. So this is getting a little close to the limit, where this tool says you shouldn't be consuming that much processor. Now it's gone red. I would expect that in a benchmark. You want to pin the processors if you're measuring process performance. I mean, if you don't, then you really don't know what your capacity is on the machine. So it also shows you down here the transactions per second, kilobytes read per second, kilobytes written per second, then the read and writes down here in kilobytes. So, and this would be by device. So let's stop this. I think you get the idea. Let's run a write test, or excuse me, a read test. I'm going to fire up FIO to do this, or file IO. And so, yeah, this is a retest, and so yeah, it's going to have a little bit of write because it is writing out some information to save off for the benchmark data. And then this is the actual performance. Now you notice it's nowhere near the channel speed for SATA, so it didn't go purple, but it is smart enough to know that. It does know that. All right, so let's try a write file, and this time it should flip over to here. So you can kind of get an idea of how this works with the iostat. I think iostat you'll probably have to install. More than likely, you'll have to install that one. I know I did when I brought up this. So that's finished. So now these should all zero out, probably on the next cycle, or roughly zero out. Yeah, they've gone back down. So yeah, that's iostat, and you control C out of it. Same with VMstat, you just control C out of it because they're just going to sit in a loop and monitor forever. And of course, you also have top. Most of the distributions I run across with Linux all have top on them. htop, of course, you have to usually install. But anyway, it gives you some information about, this is the uptime in days, hours, and minutes. And then it says there's one user on the system, and then the load average. This would be the kind of an aggregate load average. I think it's in 1 minute, 5 minute, and 15-minute intervals. So yeah, so it'll just kind of give you an idea that you had 2.23 processes running, 2.2, 1.9. It doesn't give you percentage of the CPU, although I think that is actually part of the calculation. But this is really meant to tell you, okay, so out of 8 cores, you have 2 running pretty much all the time. So, which would probably be true because the system processes are going to try to lock into one processor and the user into another on a light load. Got about 355 tasks running in the system. They're just that would be scheduled, not running. Of those, 351 or so are sleeping, and right now 2 are running. If I had any stopped, that would be a command stop. From the command line to tell the program, tell the kernel not to execute anymore on that particular process until I tell it to go. A zombie, I kind of touched on this on one of the earlier videos, but I'll just tell you again. If a process, one of these tasks down here, process task, same thing. If one of these tasks down here spawn or fork another task, then that forked task becomes the child to the one that executed the fork. If that parent task, and that's called a parent, if that parent task were to suddenly stop or die, the child process keeps going and it becomes zombied because it reverts to the root process for management. And if it stays in that state for very long, in other words, it's trying to run, but it doesn't have a parent to control it, Linux will sweep and look for zombies and blow and take them out of memory. It'll just remove them. So yeah, so that gives you an idea. If you've got this would indicate a software bug probably that your parent process is dying unintentionally. Now there is a way that you can have the parent detach from the child so that the parent can then go to a stop, but without creating a zombie. But this would indicate generally that there was some kind of failure in the code. Then we have an aggregate of the CPUs. This would be all threads as well. So then in my case, this would be all 8 threads. The percentage of the user system and nice or NI. Nice is as the same as what we talked about before. It's a priority of execution. Amount of the time the processor is idle, how much is waiting on I/O, and then we have the cycle stealing again down here. This is swap. This is cycle stealing. Memory, how much total I have, how much free I have, what's used, and how much was pulled into the buffer cache. So not a lot of memory being used here. And then if I had any swapping going on, that would show me an indication here of the percentage of disk that was holding swap memory files or yeah, swap memory files into it. And then, of course, you have the same thing you would have on a PS, right? The PID, the user, the priority. Now, you'll see some, like there's one that's negative. And there's a nice that's minus 11, minus 20. So, yeah, these would be system processes over here on the negative nice. Then you have virtual memory, resident, shared, and then percent memory, percent CPU, and the time that the job has been sitting in the queue, and then the command itself. So there's also a help that you can go over here and you can look at. You can kind of change the way the system displays the information or the detail that it provides, and so you can look at the man pages. And for that, I'll show you just a couple of things you can do. So instead of this aggregate, so if I want to see the breakdown by CPU or by thread, I can do that, and I can kind of get an idea of the balance of my system. So. Yeah, I'm not running a lot, but it is pretty balanced, more or less. I'm equally executing on all cores, and then same information if it was over here, and then if I want to take that back off, I just hit 1 again, and do that. Q to quit on this one. I'm not going to spend too much time on top. Top is another tool you can use because it's in the system. It's so you don't have to install anything if you're looking for a problem. But this is probably one that you're probably all very familiar with. So there is a help for this, and you can see that these are the color codes for the CPU bar, and this is the one for the memory bar and the swap bar. So blue would be low priority normal. This would be something that was niced. This would be normal kernel. This would be a kernel task, and this would be stealing. This would be the stealing percentage. And then you have memory bar used, buffers and cache, and then swap red. And then you have some other things you can do here. If you want to kill processes or you want to change the order of the data that's displayed, you can do that. And then you just hit any key to return. You'll notice that I do have some blue here. That's in memory. I don't have any blue in here, so I have basically user and system processes running. No cycle stealing. But if I did fire up a VM, you should see some of that. And then, of course, I have 180 tasks, 604 threads, and one running, load average 1.2, more or less. And then my uptime. And then it'll list down here all the stuff: PID, user, priority, nice, virtual memory, resident, shared, CPU, all that stuff. This is status. So R is running, S is kind of sleeping, kind of waiting. And there's some other ones in here that for blocked and all that stuff that it's kind of waiting on. So if a task isn't really doing anything at the moment, then it just goes into a sleeping state, waiting for the processor to come back and execute code on it. So that is htop. It's a good tool, for a daily use. But if you're trying to fight a problem or you're trying to find out where the problem is, I would recommend Glances. Glances actually will tell you a lot more detail. It'll show a lot more information about when you're having an issue and where the issue is. So it helps you kind of narrow down to where you have a problem. It uses the same code. Green, everything is good. Blue says it's normal. Purple says you're getting into the, keep an eye on this stage. And then red means you might want to take a look at this. You've definitely got a problem. Now, I don't worry about it so much when it's down here on a single core with a single app. That's okay. OBS, we know, takes a lot of CPU, but I'm not too worried about that. I would be more worried about, what's it doing aggregate-wise to the system, and it's not running me out of gas yet. So let's cause it to run out of gas. I'll go run my sysbench again, and this is going to ramp up 1, 2, 4, and 8 threads. And so you should start to see, as it comes back around, down here is where it will display any critical alerts. And so, we're starting, or 70%. It should click in here. There it goes. So it's telling me I've got a high CPU user mode. It's telling me that this task is in user. So it's in user space, so it's going to be one of my tasks that I'm running. And, of course, it's sysbench. You saw it was 689% there. So it was running on 7% of the cores, and I have one that's pegged down here with the OBS. So yeah, there's blue, that's normal. That's okay, don't worry about that one. Red, that's bad. And of course we got another alert down here as soon as that triggered. Purple means keep a watch. Yeah, so nice tool for that. There's also a help for this. There's a lot of different things you can sort by. There's you can look at interrupt rates, you can look at disk I/O rates, but you can change some of the information that the network displays and the disk displays, so that you can help you kind of figure out where your performance bottleneck might be. And that's really what that tool is designed to be used for. And I use H to get back, so use help to get H to get in, H to get back out. It's not like htop, but yeah, you can here. Let's do a sort on memory. So right now it's showing me the processes that are using the most memory. And go back to C. These are the ones that are using the most CPU. So yeah, you can reorder these. Let's do my files benchmark again. And this time down here, we'll start to see read and writes come up. Now, I think it's, let's see. I think the I/O is, we can use a T, I guess. Yeah, we'll try that. It's showing the, yeah, well, maybe not. It's not showing anything because it's finished. All right, let's try a write now. So now it's telling me how much data is being written out per second. So I can go back to the other one. So yeah. Again, if there's any critical alerts, I didn't approach the channel rate on that device, so no big deal. As to which tool I like to use htop for the most part. I find that useful on kind of on a daily basis to kind of watch how processes are running. And then if I do see something wrong, I'll bring up glances and use that to actually try to narrow down as to which process it is that's causing problems. I think later on in this, when we start, excuse me, when we start looking at some of the ways to actually do performance tuning, I'll show you how you can use this tool a little bit more and how to actually determine what things need to be performance tuned. You know, every application is different. Some applications are going to have background processes, and so you're going to want to tune a little bit more to the background processes. Some of them are user-oriented, so they're foreground processes that you're probably going to want to favor your execution toward that. If you're running a database or you're running a lot of I/O, then yeah, you'll probably want to favor some of the I/O over the execution on the CPU. So it's a balancing act. You're giving up something to help improve something else, and as they always say, once you fix one limiting factor in the system, something else becomes the limiting factor. So you usually make several iterations through the process until you get it tuned the way you want. But anyway, I hope you enjoyed this video today. If you have any questions or if you have any suggestions on a tool that you really like, I'd be happy to take a look at those too. But these are the ones that I like to use. VMstat I don't use very much anymore. Sometimes I use it. iostat I will use to kind of get a snapshot. It's the one I use when I'm trying to figure out if if I'm choking off one of if I'm choking off performance to the CPU because I'm bottlenecked on the I/O, I'll use iostat to try to do that. And then if I can't figure it out, then I'll use glances to go actually drill down into it and see what interrupts are actually causing the issue. So I hope you enjoyed this today. If you did, please like and subscribe. And as always, hope to see you again real soon. Bye for now.